Hello everyone. In this video we will discuss on the sectioning part of isometric to orthographic conversion. Sectioning of an object plays an important role while we need to see the internal feature of any three-dimensional object. So I have taken the previous example. In our last class we have converted this problem. We have converted the isometric view of this problem into the orthographic multi-view, and we got this result. We have got this result where this one is the front view, this is the top view, and this one is the left hand side view. Now if we want to see the internal feature of the object, then we will be needed a section plane. Section plane is basically an imaginary plane which, if we insert within an object, then we can see the internal feature of that object. Similarly, here also if we insert this section plane within this object, then we can see its internal feature. So now if we check this figure where if we insert the section plane within this object, then we can see the internal surface of this object. That means these surfaces can be seen, like this surface can be seen, this surface can be seen, and these surfaces can be seen while we will insert the section plane. So while we will insert the section plane into the object, then the surfaces which will be in contact with the section plane, those surfaces will be represented by the hatch lines. If you notice this front view of the object, then you can see that this portion, the portions which are hatched, these portions will be in contact with the section plane while we will insert the section plane within the object. But these are the portions which are not hatched. These portions these portions will not be in contact with the section plane. As a result, these portions will not be, we will not represent these portions with the help of the hatch line. Here in this portion, in this part, this arc can be seen. So we should draw that arc from this point to this point. This can be seen over here. So this is the front view of the object while we will insert the section plane. Similarly, while we will see the object from the top, we can see this edge of the section plane, and this edge of the section plane is represented by a line. The name of that line is cutting plane line. So now if we see the top view of this object, then you can see this pink colored chain line. This one is basically the cutting plane line. Now in the cutting plane line, these arrowheads represent that this part of the object will be in the front view, but this part of the object will not be in the front view. So basically we can see this portion, the portions which will be in contact with the section plane with the help of this section line or the hatch line. Now the section planes, the cutting plane lines are generally represented by these chain lines, and at the ends the arrowheads are used to represent that which object we are considering. Now we always get the section portion of the object in the view, and it will be decided based on the orientation of the section plane. Like in this example, the section plane is parallel to the vertical plane, as the section plane is parallel to the vertical plane, so in the vertical plane, in this case, the view that we will get, in that view we will get the sectional view. So as the object is in first quadrant, so in the while we will see from the front, we will get the front view of the object in the vertical plane. Now the section plane is parallel to the vertical plane. That's why in the vertical plane we will get the front view, and in the front view we will get the sectional front view. So we will get the sectional view of an object when the section plane is parallel to a certain plane. But as the section plane is perpendicular to the horizontal plane, so in the top view we cannot get any sectional view of the object, but we will get the position or the location of the section plane, and that location will be represented by the cutting plane line. Similar to in the side view also, while we will see from the left hand side, we can see this edge which represents the location of the section plane. So this location of the section plane is also represented by the cutting plane line, and it will be represented by these arrowheads. Now if this edge is represented by A, then we need to represent this edge of the section plane with other letter B. Okay, so in this way the section plane are used to see the full sectional view of an object. Now you may be interested to get the internal portion of this part of the solid also. So in that case we will use the concept of half sectional view, where the section planes are half of the section plane will be parallel to the vertical plane and perpendicular to the horizontal plane, and half of the section plane will be parallel to the profile plane and perpendicular to the horizontal plane. So in this case you can see that this white colored part of the solid, this part is basically will be removed, and if we remove this part, then we will be able to see the internal part of the solid, that how it looks like. So now if we check the half sectional view, then you can see that when we will see from the top, we can see this edge of the half of the section and this edge of the half of the section plane. So basically we can see the location of the section plane in the top view, because the section plane is perpendicular to the horizontal plane, and in the horizontal plane we will get the top view. That means in the horizontal plane we will get the position of the section plane, so that position will be represented by the cutting plane line. So in the horizontal plane, in the view that we will get, in that view we will show the location of the cutting plane line. Here also, as this part is represented by A and this portion is represented by B. Now if we look at the front view, in the top view you can see that this part will be removed. Now if this part is removed, then we can see this portion as well as this portion. So this part, now when we see from the front, we can see only this part cannot be seen. So now if we check this front view, while we see from the front, we can see only the section or internal feature of this part, means the internal feature of this portion, but the internal feature of this portion cannot be seen in the front view. So that's why that is represented by the hidden line. But when we will see this object from the left hand side view, at that time we can see the internal feature of this part, but we cannot see the internal feature of this side. Okay, so with the help of half sectional view, we are able to show both the surfaces or both the faces of the object. Means we are able to show the hidden features of the object in both the portions. means in this part as well as in this part. So it depends on the object, how the object looks like and what type of section plane is required, whether it is full section or half section. It is totally depends on the shape of the object and what are the hidden features or internal portions we are interested to see. Based on that, we will adopt the full sectional view or the half sectional view. So let's take one example, that whenever you will convert any object, means whenever you need to draw the sectional view of any object, at that time, at first you first imagine that there is no sectional plane. Now if there is no sectional plane, then we will draw its front view, top view and side view that I have drawn over here. Now after considering that there is no sectional plane, we will draw this front view, top view and side view. After drawing that, next step is, now we will find out that if there is a full sectional view, then which parts will be visible. So here you can see, if it is the full sectional view, then these hidden portions are no more the hidden part. So as these hidden portions are no more a hidden part, so we will convert this hidden part into the visible part. So we will change the properties of the hidden part into the visible part. So we will change the layer into the visible layer, as it is visible. So we will convert it into visible layer in this way. Okay. Now you check that after that is this part means this edge. Is this edge visible? No, this edge will not be visible. So as this edge is not visible, so we will trim this edge. So we will trim this edge, as this edge is not visible. So we will trim this edge. Now this is our front view. Now in the front view, we will get the sectional view. So to represent the sectional view of the object, we will take help of this hatch option. So if we click on this hatch option, we are asked to select the zone, or we are asked to pick the internal points. So this is my internal point. Now you can see, if I move my cursor over there, then a preview is showing that what type of section line will be shown. Now the shape of the section line will depend on which material we are using. But commonly used section line or sectional pattern is this one, which is at an angle of 45 degree. So we will now, if we move our cursor on the space which is in contact with the section plane, and we will click on that space. If we click on that space, we can create the internal feature of the object. So this is my front view. Front view is completed. Similarly, in the top view, we cannot see any sectional plane. We cannot see any internal portion, as the section plane is perpendicular to both HP, is perpendicular to the HP. So here we need to show the arrowheads from the downward to the upward direction, because this part is the remaining part and this part will be the removed part. So from the downward to the upward direction, we will show the arrowhead to represent the location of the cutting plane line. Similarly, when we will see from the left hand side, we can see this edge. This edge is basically placed at this midpoint. So at this midpoint, we will represent this axis as the cutting plane line, and we need to show the arrowhead in this direction that will represent that this part is the remaining part and this portion will be the removed part. Okay, so basically there is no such difference between the normal isometric to orthographic conversion and the sectional view. You just have to keep in mind that if there is any we have to use any section plane to see the internal features, At that time, initially we will imagine that there is no section plane. We will draw its front view, top view and side view. Then we will go through that what is the location, what is the position of the section plane, and based on that we will find out which part of the object can be seen and which part cannot be seen, and based on that we will draw the hatch lines in the zone which are in contact with the section plane. So in this way we need to solve the problems on the section plane. Thank you.